So today I want to take a look at this DuraFlame heater. I have it plugged in, and as you can see here, we get no display. It won't come on. I have a feeling something's wrong with the control board here. Harvey Dog said yes, broke all right. Well, we've had this heater for quite a while, and it just stopped working on us. Nothing obviously wrong with the transformer and power supply board. Nice fan here. The blower itself is nice. Only 20 watts. That's pretty cool. A little dusty. It's been sitting for a while, but I doubt the filter's even that dirty. Nope, not really. While we're here, there's our little NTC, by the way, for our sensor. The temperature control was not good on this heater at all, but the NTC plugs in right there. So I'd already taken the cover off to look inside there, and now I'm going to take off the bottom bolt. Looks like it just holds the wood to the metal can. So we got 4 more of these. It's 5 total. And here we go. After moving those 5, we just slide the can out. We're going to remove these 4 here. We'll take a look at this control board. Back with those 4 Phillips heads removed, and here's our control board. We just got to remove these 4 screws, and we'll take a look at it. So back now on the bench, we have the power supply as well as the control board. The power supply was on the back side with the spacers. I got this out on the workbench here, and I have used a ribbon cable that I had, but this ribbon cable did not switch, so I put these little individual jumper wires on here. I don't know if you could tell in the video, probably not, but I could tell looking at it that the ribbon cable was flipped, and this is just a straight cable and it's not flipped. So I'm flipping it here with these individual wires, and I think it's going to help me troubleshoot it as well. I can take these wires loose and check if I need to. I have this hooked up to a quick test, and I have this separated out here. Now this is 120 volts. Anything you do with high voltage, you do at your own risk, so don't touch it if you're not qualified to do so. So as you can see here, my hot, my neutral, and then the fan is what plugged in this on these pins here. So this is my hot, and it's insulated, and then I have a neutral with a pin and socket connector here, just slid onto the neutral to make sure they don't touch in any way. And over at my quick test, I also have those to make sure they don't touch each other. They're insulated well, so they won't touch each other. And we close our quick test. We'll see if it comes on. And even though I don't know everything about this board, it's probably going to be a 12 volt or 15 volt. And it's got 2 caps, so probably a 5 volt or 3.3 volt. So we got, besides the relays, we just got some diodes coming off the transformer for a full bridge rectification. And if I had to guess, these caps right here, the large one's probably going to have 12 to 15 volts DC. This is not a regulated supply, just by the transformer itself. And coming off the diode bridge, and yep, right at 13 volts, perfect. The smaller cap, okay, 5 volts. So 12 volt and 5 volt rail. And this board is probably good, other than testing the relays, but the relays were not a problem when it quit working. The control part just quit working. I had this little piece of Formica here because if this lose connection, I can hear the relays clicking. You can probably hear that. That's letting me know that we lose our pull down resistor. The relay's coming on, so I guess it's giving that transistor right beside the relays a signal to fire. They're usually held low. So if we look at this, for now, let's make sure we're getting 5 volts to the board. Should be on the outside pins, and we do. Of course, it's going to be switched over, so it's going to be this way. Yep. So we know we got the supply correct. I have nothing on the pins back to common. But if I take this loose, we definitely hear it click. Yep, 11 volts. 11 volts. So both of those coils across that suppression diode, you can tell there, we are pulled in. We have no number on this microcontroller. It has been etched off, but I believe the microcontroller is dead, because if I check somewhere in the middle, usually we have our 5-volt supply on microcontrollers, just typically. I have no idea which one this is, but yep, we know we have our 5 volts available to the board. But we actually have nothing. We just go across these pins for the resistors that would be lighting up the display. I mean, nothing. This whole board's just dead. So this board did have an infrared remote that could control it. And as typical, if we look here at the remote, I'll put a small video in the top left for the remote. As you would think in storage, yeah, all corroded up. So that's about how those stay, you know. So I don't really want to get this control going that bad anyway, because I think I mentioned already it was not very good. I mean, the heater put out very good, but the control for it, like if we had it in the bedroom during the night, it would just start coming on and it would get warm. Even though you had it set like, say, 63 or 64, it could be 70 degrees in there and the thing just starts coming on. It just didn't regulate well at all with the NTC or the way they had it set up anyway. So I'm interested though in making this for like a shop or my garage heater. It's just too nice of a heater not to figure out how to easily make this work. And of course we could just make it come on, and you can flip a switch, right, and you can make the heat and the fan come on. But even in the garage, I would want it to be temperature controlled if I'm out there working. So I think this is going to be fairly easy. Our 5 volts is coming from our power supply board and coming back. And it's 1,000 ways to do it, but if I just jump here, we can hear this click. Now I can go ahead and tell you this is just for testing. This is not going to actually work, well, not long term, because see, the voltage here is 9.5 volts. I kind of suspected that just testing with a 5-volt jumper. We're saturating that transistor. It's only really needing like 0.7 volts to turn on, right? So I'm going to have to put a resistor in line with this. So just for testing here, we'll verify that the relays are pulling in. But we are we're pulling down probably the 5-volt supply when we do that. Let's go ahead and look inside and make sure the element's still in good shape, because this heater was in tip-top shape when it quit working and didn't have a whole lot of years use on it. So these are the quartz infrared type heater, and they do a really good job, and everything in here looks to be in good shape. We got several elements. I'm going to put power on one here, and we can see it's working as it should. I just have my inspection camera in here so we can safely do this without taking it all apart, but I do like it. I do have the blower on while I'm doing this to cool the element. And as a matter of fact, I want to pull the power and see how long it takes for the element to stop glowing or to cool off with the air blowing, because that might come in handy later. But for now, we'll move on to maybe adding a thermostat. This is just an easy way to do it. It's a battery powered thermostat, fairly cheap. I even keep a couple around typically. This is a heat only, so like I would use for my fireplace, you know, gas log set, I have it coming on and off with a thermostat as well, very similar to this one. And it's just powered by AAA, so that's cool. And we should just be able to come off the relay contact to power on the fan and the heater. So I just got one wire going in as like a common and 2 coming off from the same relay contact here, so I can play around with making the fan and the heater come on off control, and of course thermostat. I think this will be so much better, even though I'm not going to really use this in the house unless it was for emergency heat or something. I still want a good thermostatic control, and this is going to be great. Probably mount to the back so it picks up the air coming in. So we just simply plug this into the terminals on that plug 1, the plus 5 volts, and then go into the fan and the heater, which will be the first pin and the third and the fourth from the bottom to the top. So we see here we have a plus 5 volts, then where the NTC was, then the fan, the heater, and the common. Display lights up nice. Let's see how it goes here. Yep, there we go. I heard the relays click. Well, all 3 actually, the thermostat as well as the 2 on the board. Make sure we cut back off. We hear it drop out. Yep. Back on. Alright. So as I mentioned earlier, this board here, you cannot see the microcontroller part number at all. And the board doesn't look bad. It's in really good condition as far as physical condition, but it really didn't work that great anyway, to be honest. So we won't worry about that microcontroller. So here I'm just going to use my tweezers to measure on the board in tight spots, and I'm getting almost 6.5 volts across this resistor, and ooh, it's hot to touch. Resistor's definitely getting hot as we're overloading that circuit, just jumping the 5 volts to the transistors here for driving. They do pull in good, but the voltage is pulled down even on the 12 volt rail also. So if we go across the actual relay itself, the diode, we see 9 volts, just one right now pulled in 9 volts, just making sure it's working correctly. Now the other one for the fan. Go across it and yeah, about 9.5 volts. So yeah, it's really hot. Let's see what the current's doing here. Just put our meter in current. I can actually use the tweezers to go across on this low current, and 5 volts to fan. So for the heater control, we have about 195 milliamps, and then on the fan about 185. So that's actually about to burn the transistor up that controls those relays. And as I mentioned, we had resistors on this board. Those were, I believe, 2.2K, and I have a little decade box here. I'm going to go to 2.2K, and then we can jump this from our +5. You see we got NTC, then we have fan, then heater, then common. So we'll go from our +5 volts to our fan, and then we'll go from +5 volts to our heater. But we'll use the 2.2K resistor this time through the decade box. And I can show you the current difference by doing it like this with my tweezers, which are just showing milliamps on my Kawitz meter. And look at there, 4 milliamps, and yep, 4 milliamps on both, and that resistor's cool as it should be. And since the relay pulls in, it's probably plenty of voltage. As long as we're getting around 0.7 volts, the transistor should switch. We could even go higher with resistance. Now we're at 4.7K, and we're barely getting up to a milliamp, but the relays are pulling in, so even that's probably really close to 0.7 volts. So let's hook it up and see. We'll go back to volts here on our DMM. 0.7, oh yeah, that'd definitely trigger there. Cool as a cucumber. Yep, right at 0.75. So that's going to be the way I want to do it, switching from the thermostat +5 volts through a roughly 2.2K ohm resistor. And yep, we got 12.3 volts when we do that. We're not loading down that board anymore. The power supply's got a little room, and 11.5 volts, so we're doing great there. Well within range for the relay. So one thing we could do, I have a large capacitor here, and we could play around with putting the capacitor value in and cutting on the heating element and the blower at the same time like I had discussed. And we could put this capacitor across like so, and when we cut on our relay, we also charge this capacitor up, and then we should have, you know, a 5 to 10 second delay depending on our capacitance value. More like 8 seconds, but this is a fairly large capacitor. It seems to be working fine. I just don't know that's going to be enough delay for us. Well, the largest capacitance value that I have is this small at this time. I'm going to try to show the heater up in the top right. As I was monitoring the cool down, you can see it cooling off, but you can tell it was still glowing a little bit. So at about the time that the relay would have dropped out, so what I can do is just simply use the thermostat for the heater only, and I can just do my control power with a switch like this, and just let the blower come on when I have control power on, because it's only 20 watts anyway. I bought this switch because it was one of the few that would let you mount it flush and have the wires coming out, as I think we need to do on the front to make it look nice and not have terminals actually sticking back going towards the metal cover, obviously. And I like everything about the button. It's just a little bit cheap made and it don't want to click every time, but I do like how it's low profile, and we'll hook it up here and see how the wires go. Probably pretty obvious. It should be black and red should be supply, and I'm assuming your yellow should be switching. And you don't even need the common if you don't want the light to work, but I think it would be good to be able to look at it and see the light real dim lit up in the front. See if that'll work. Yep, that's it. So we could do this, and once we activate the control power, our blower comes on, and that also feeds power to the heater thermostat to allow the thermostat to be able to work. So I think that might be the way to go. I like it. And we'll of course put that resistor in line with it, and we should be good to go. Now if we tie a thermostat in just to do a quick check here, I'm only going to use one of the wires coming off the relay, but give it power and then flip this on, and there we go. Yep, that'll be just fine. Yep. We can cut our control off and we're good. I don't even have to drill a hole. This thing was already kind of in bad shape on the push button. I guess we turned the temperature down a lot. I want a pretty flush mount button here. Sorry, I was off camera here, didn't realize it. I zoomed in too far. I'm just putting tape over the hole. I had bought some wide vinyl tape. It wasn't quite the color or satin as much as I hoped, but it's going to be fine. It's just for the garage anyway, but I just wanted to cover that mylar and where the wire goes in. But that switch is going to work out great being low profile like that. I'll probably come back and put another layer of tape, but I don't have to do it on video. So back now with the resistor, I'm going to solder this on to the yellow wire and put some heat shrink on it. Put some rosin flux on there and a little bit of solder on the tip. And there we go. Maybe just a little bit more. There we go. So now that we have the resistor on here, I'll show you this little diagram. Looking at the board like this. This is how a connector is. And we had mentioned this earlier. 5 volts all the way to common. Our NTC was used there. So the second pin is no longer used. We'll be using the fan and then the heater. On the original cable has the color chart you see here: black, green, blue, yellow, red. It was flipped on the other end, but on this end that's how it was. So our red is going to go to our plus. Black of course goes to our common. And of course that common is really just used for the light. If you don't care for the light, you don't have to hook that up. But the yellow now has our resistor, and that'll be our power that goes to our fan. And it'll also go to the thermostat, and the thermostat is what will switch and go to our heat, but only if we have control power from the push button. So that should be good to go. Get a little bit of heat shrink here. I do like these Wago connectors, especially when you're just testing things out. It's just so easy to have that terminal the switch on there. I'll put it together like this, and I might go back and solder everything together when I get done, but I mean, I really don't have any issue with these Wagos. They work great. I had some battery balancing connectors, and I actually made up a connector for these, and I'll put them on here, and I'll be able to plug this into the other end of the cable that was original that goes back to the board. I just had to remember that it is backwards, and then we'll be good to go. So here we go. It plugs in like so. I think these Wagos will be fine. It's close quarters in here, but it's not going to get hot here. This is where the air is blowing across. They've already had plastic in here previously, and even this cover is plastic. So let's just put the cover back on. Just 4 Phillips screws. We got it flipped over sitting on the front, and we can put this board back on the little insulated standoff bracket. Just 4 Phillips screws back in this board. There we go. Now before I plug this connector up, I actually need to pull the wires and separate them. This was like a little ribbon cable all stuck together. I'm going to separate the wires here because I have to cut 3 of them. Put our diagram down here. We're going to cut the yellow and the blue. So we're going to let the red and the black go out to the front board. I'm going to go ahead and drill my hole for my thermostat. You can barely see it, but I have marked it with a small felt tip marker. It's the 2 little mountain screw holes, and then the small wires, so not a big hole here either, for the wires to go. Get the Dyson and clean this up. I also have a video modifying the Dyson to run off a Milwaukee battery if you're interested. So now we're just going to put our wires in for our thermostat. I'm going to mount it with some screws with some washers and hex nut on the back. I will take the NTC out while we're at it, because I will never use that again. I don't know why it didn't work well, but it was not very consistent at all. Most NTCs are very sensitive, but I don't know why that one. I guess the controller itself was just not made well in this DuraFlame. So I'm going to break the blue here so I can put it together. And that's going to go to our thermostat. Then I'm going to strip the yellow. It's going to go to the other side of the thermostat. Just going to put them together and then put them under one side of the Wago, and then that's a really good connection there. Yep, looks good. We'll just plug this into the power supply board. We got to plug in our heat connectors to our heater, and of course the safety switches have not been tampered with. The safety cutouts are still there. We're going to plug up our power in and then our fan connector to the board here. Just double check all our wires. We should be good to go. Get up our trash and our little diagram. We'll just push our thermostat on, and there we go. 4 Phillips screws, and we'll put the back cover back on. We're going to slide the metal can back into the wood housing. just got to put these 5 bolts here on the bottom plate into the metal housing, and that lined up even better than I thought it would. Now, never use a drop cord to run a heater. The only reason I'm doing it here is so on camera you can see the kilowatt meter as I'm showing you how the heater's performing. It's not safe to use drop cords with heaters, obviously. They're just pulling so much current, it's too easy to overheat and becoming a fire hazard. Right now, I have this in off. I'll flip this around and show you. We'll cut the fan and the control on, and our light comes on. That's great. Probably can't hear that, but the 20-watt fan is running. Let's see if it shows up. 120 volts. Yep, 20.7 watts. Alright, so let's cut the heat control on, and let's take the thermostat up. And there we go. 1400 watts. 12.2 amps. Of course, our voltage has dropped because of the drop cord down to 114 volts, which is not great, but that is a lot of load. So even though this drop cord is heavy duty, it's still not meant to run heaters. Make sure our thermostat is controlling. And there we go, back to 20 watts. Well, that was a really easy repair, honestly. And it saved this from being thrown out because it was such a good heater. I mean, I hated to throw this thing out when the heater's putting out. I mean, it's a really, really nice heater, and the thing works really, really well. So for less than 20 bucks, I mean, I got the thing working. I think it's going to come in handy in the garage in the wintertime. So I hope you found this video helpful today. If you did, please like, share, and subscribe. I'll have some links down in the video description of some of the tools and items I find helpful on my workbench. And any of those links you click on are affiliate links, so they help support the channel, and I greatly appreciate it. So thanks so much for watching, and God bless.